Hello everyone, I'm Shelja Rai, Product Manager at Practice, and I'm super excited to have you all here for this hands-on masterclass, SQL programming using food delivery app. We have designed this session to be practical and real beginner friendly. Let's take a quick look at the agenda and then dive into the data. First, I will share a bit about Practice, who we are and what we stand for. Then you will get to meet our instructor, Rahul Nikra sir. We will walk you through the objective of this masterclass. We will go over the dataset overview. Then the real learning begins as Rahul sir will walk you through use case implementation. Finally, we will talk about how can you continue learning through Practice offering, including a special bonus just for attendees. Now let's talk about Practice. Practice is a platform designed to help you learn by doing. We create real digital products like business requirement, use cases, data sets, and capstone projects. Our mission is to help you become part of the top 1% by bridging the gap between theories and practice through hands-on learning. Now I'm excited to introduce our expert for today, Rahul Nikra sir. He is a solution and data architect with more than 17 years of experience in data engineering and analytics. Sir is skilled in SQL, PostgreSQL, Snowflake, Power BI, AWS, and Azure, and currently work at GSpan Technologies. Now let's talk about the objective of this masterclass. We are focusing on how to use SQL in real-world context. You will learn how to query and analyze restaurant and order data, extract performance insights, solve real business problems using structured SQL logics. And all of this will be done with a simulated food delivery app dataset to make things practical and relatable. In this masterclass, you will be working with a data set that mimics the structure of real food delivery platform. These are the data sets you will be using. And now I would like to hand it over to Rahul sir, who will be taking you to the core of today's masterclass. Over to you, sir.
Okay. So this masterclass is basically targeting to cover up the basic SQL programming stuff using the SQL Server database technology. We are going to use this synthetic data source called as Zwiggy. Then we'll show the queries, what use case we can solve using that data set. So let's look into this. So basically in this particular masterclass, we are going to cover up the basic SQL joins like inner join, left join, right join, cell joins, and then look at the common table expression, few aggregation functions, query and core subquery and correlated subqueries, and then how do we create the store procedure and function into the SQL Server. So that's what we are going to cover up in this masterclass. Let's look at the context of the tables. So in this entire session, we are going to cover up all the examples using these two tables like employees and departments. So look at the employees table, which has 3 columns and departments has 2 columns. Employee table has like employee ID, name and department ID, and department ID in employees table is nullable. And you can see there are like 4 rows. Alice has the department ID 10, Bob is 20, Charlie is having 30, and David is not assigned to any department yet. Similarly, if you look at the departments table, it has 2 columns, department ID and department name, 10, 20, and 40. 10 is belonging to HR, 20 to IT, 40 is going to be assigned to marketing. But if you see here, the 30 department ID, which is there, but is not having the existence into departments table. So let's remember this particular, these 2 tables, which we are going to use as part of our example in this learning session. So if you look at this inner join, so the definition of inner join is that when we join 2 tables using the inner join, it returns the matching rows from both the tables. So return only the records with the matching values in both the tables. So the syntax of this particular join is inner join between 2 tables and put up the joining condition, department ID and department ID from both the tables. So now you can see there's a name and department name, Alice Bob, 2 rows are returning by this particular query. The reason, if you see the Alice and Bob, for both of them, department IDs are existing into the departments table, and that is why we are getting the Alice and Bob as part of a result from this inner join. So it is a basic and most used join in the SQL queries, SQL programming. Let's look at the second join, that is the left join or left outer join. So in this particular thing, you can see that syntax is like left join. We are selecting the data from employees and putting up to the left join from department. So what it does, it always returns the data from the left hand side. So for example, what does it mean? The left hand side is, to keep remember always, the difference between left and right join is, it is very simple. So you are sitting in front of your screen, left join will always be return the data from your left hand side table. So that is your employee. If you put in perspective of left and right, and the right hand side table is a department type. So any table which is coming after from is always left hand table, and the next table which is coming after the type of join is always the right table. So we are joining here using the left join, and you see Alice, Bob, Charlie, and David are returning HRIT, their respective departments, what it is mapped to the department ID in employee table as part of the mapping, and the Charlie and David's departments are coming null. The reason, if we look at the actual data in the table, since we are returning entire data as part of left join from employee table, so Alice, Bob, Charlie, and David are returning, and their 10 and 20 IDs are existing. That is why their departments are showing HRIT. But Charlie and David department's IDs do not exist into the department table, and that is why the values for department name are coming null for the Charlie and David. So that is the left join for you. Let's talk about the right join. So right join is just a vice versa of left join. You can see we have the same query except this right keyword in the select query. And the records which are coming from this particular query is Alice, Bob, null, and returning all three departments. So let's go back to the data set. We have three departments, HR, IT, and marketing. Two respective allies Bob are returning their department names, and rest of these two rows are escaping from the output. Reason being, we are selecting the data from department ID, and that is where the marketing is showing as part of the row, but with the name as null. So this is the right join for you. Let's go to the self join. So there are scenarios where we have to join the tables by itself. So self join is one of the join which actually help us to do the recursive joins itself. So you see the syntax where we are joining the employee, giving the alias to employee table A, and joining the employees table B, giving the alias table B, and then joining based on the department ID A from joining department ID from B, that is employee B. And we have put up the condition. So the condition in the self join works on the this condition as well as what we are checking. Employee ID from A and employee ID from B should not be matched. So what it is returning, it is saying us as part of the output that Alice and Bob are having the same department, and that is how we connect that particular table. One of the use case of the self join. So assume that this particular table, assume that you have the employee ID, name, and department. Let's assume Ali's manager is Bob, and we will have the employee manager ID another column where we can put up the additional column for Ali's is 2. So in that particular scenario, we can find it out, okay, who is the manager of who. So that is the scenario where we keep the two columns, employee ID and manager ID. So manager ID is nothing but a employee ID of the employee to whom he is reporting. So that's how the self join actually help us to join the tables itself, and then based on our business requirement, we solve the use cases. Now come to the table, common table expression. This is one of the most effective and most powerful syntax or the way of doing the SQL programming, because this help us not only to simplify the SQL queries, but also help us to read the code and achieve the performance in a better way. So common table expression is a kind of temporary results which is like within the selected space itself. So is a selected scope, and I'll explain with the example itself in later part of this session. So mostly it is a kind of statement which is supported by most of the database platform like Oracle, SQL Server, Postgres, Snowflake. So any database tool you go, be it on cloud or be it on premises databases, it supports by most of the database platform. And as I mentioned that it often used to simplify the complex joins and allow to us remove the subquery and correlated subquery. And the syntax is always start with and the we have to put up the name of the city and list of the columns which is going to written by the inner query, and then close the parenthesis start as, which is like inner query inside as within the parentheses, and then we select the data from outer query. That is the syntax of the CTE. We'll look at the examples later in our Zwiggy dataset, how we are writing the CTE inside that. Now look at the common aggregate function. SQL Server has two type of the inbuilt SQL functions, and we can write the custom functions as well. And these functions like aggregate function like count, sum, average, mean, max, these are the functions which are basically inbuilt functions. And aggregate, so there are like many other type of functions as well, like date function, like scalar functions, aggregation function. So these are the different type of function we use in our different type of query calculations. And every time when we use any aggregate function, or for that matter, writing any like total counts, like total order value, something like that, we have to use the group by. Having is the optional part, but to use any aggregate function, we will have to always put the group by clause in the SQL statement. And the name of the functions like count, it counts the number of rows. Some give you of the some of the rows or some of the column within the row data sets. The average calculates the average of the value. Minimum return you the minimum value within the data set, and maximum returns you the maximum value out of the data set. So that was the common aggregated function which are heavily used to build any sort of complex SQL queries. Now look at the subquery. So we have to write certain condition or look for the limited data within the data set. So the subqueries are the one which help us to limit the data set or set up the relationship among the two data sets itself. And it returns the immediate result used by the main query itself. So let's look at the different examples of the subqueries. If you see the first example, which is like simple subquery, where we are selecting the name and salary from the employee table and calculating the average salary. So what we are trying to find out the employee's name and their salary, where their employee's salary is like more than the average salary of entire organization. So let's suppose there are like 100 employee within the organization, and salaries are ranging from, let's say that 3 lakhs per annum to, let's say that 50 lakhs per annum, and the average salary within the inner query will give you, let's say that 10 lakhs or 15 lakhs per annum is the average salary. So what this query will return, name of the employees and salaries whose average salary is more than 15 lakhs per annum. So that's a simple where clause based scalar single value based in a subquery. If you look at the second subquery with the in multiple rows, so we are using here the in clause, right? And I believe this query somehow is not updated, but I'll show you differently the in clause in the Zwiggy data set. So instead of using the where clause, we put up the in, and it helps us to basically iterate the multiple rows. So for example, if we would like to see the inner query returns, let's say that age basket in between 18 to 25, then the number of rows would be returning by the inner query 18, 90, 20, 21 up to 25. That's how we build that subquery with the in clause. Now look at the third example, subquery in form of clause inline view. So look at the query, select reason average total as average sale, and from, we are just giving the subquery as part of the from clause and returning as a data set. So if you look at the inner query after like select reason some amount as total from sales group by reason. So this will actually give us the reason by sales by reason itself, and then we are calculating the average sales per reason itself. So the from clause will, in a subquery, from the from clause will return one subset of the data, and based on that subset of the data from entire table, we are calculating the average rather than calculating from entire sales table. Fourth example is the subquery with the adjust. So what we are seeing here, for example, select name from customer where adjust select one from orders where customer ID is equals to the order ID. So you can see it is an example of the correlated subquery where inner result is depending on the outer select itself. So these are the four few examples related to the subquery. What is the correlated subquery? It is the subquery that references a column from the outer query and it runs once per row for the outer query. So in our previous example, if you see, the customers see the column from customer table, that is the customer ID, is referenced within the inner query. So for each row execution from the customer, the inner query will execute as many as times from order tables that customer IDs are adjust. So that is the kind of subquery, correlated subquery example. We have couple more two examples like correlated subquery example. If you see the department ID, name, salary, department, we are fetching from employee and then calculating the employee average salary itself. But here you can see the employee join with the department, or I would say that from clause table is referencing within the department. So for each row from employees table will be actually executing on the subset of this correlated subquery. So whenever anybody will ask in interview what is the difference between the subquery and correlated subquery, the answer is simple. Subquery returns the subset of the data and then outer query actually process the logic based on that subset of the data, while correlated subquery is the one in which the outer query column is referenced within the inner query, and for each iteration of the row for outer query, the processing of the entire subset of data will be processed for inner query entirely. So that is where basically correlated subqueries are poor in performance, and we use the CTE to basically simplify that task to achieve the results whatever intended with the correlated subquery. So now look at the subquery versus correlated subquery overall glimpse. If you see, we have put it up like feature and the how it works. So how many times subquery returns runs very first time, but correlated subquery once per outer row. So outer row, let's say, had 100 records and subquery has, let's say, that 10 records. So for each outer query, one row, the inner query will execute 10 times. That means there would be total 1,000 iteration in the case of correlated subquery, and can be independent, yes, and cannot be independent because it reference always the outer query for execution of the inner query. Performance-wise, generally faster, can be slower on the large data set. When we write the correlated subquery on larger data set, then that becomes very slower. And the use cases are like aggregate filters and whatever the limit the row data set. And it is like a row-wise comparison and dependent logic. So the pro tip is for this is prefer join over correlated queries, subqueries when performance is critical. Use aliases wisely to distinguish outer and inner query, because if we do not the aliases means these employees E and then employees E, we can write a different alias. Otherwise, we end up to cannot find the relationship which column is connecting to outer query or inner query, and use the indexes on the foreign keys. Now look at the stored procedure. So the stored procedure are the pre-compiled object which can be used for improving the performance and basically help us to reutilize the code or the query which we need to use at multiple places. We can wrap it up into the store procedure. So the example, if you can see, we use the create procedure keywords, put the procedure name, start with as begin, and then put up the query within the begin and end clause using the this, and then this will return you. So this is the execution syntax. We need to use the execute keywords and put the procedure name, and that will return the intended output from the procedure itself. The purpose of the benefit of this is the reusability. Obviously, we need to use the select star from employee with certain condition. Then multiple places, if we are using this query, then we can wrap it up. And rather than writing the queries and with different logic at different places, we can write the store procedure and reutilize everywhere. Performance, why? Because it is the pre-compiled object. So what is the pre-compiled object? It is kind of mechanism in the store procedure where whenever SQL engine receive any query, it actually first compile and then execute the query to return the result. But when it comes to store procedure, in the case of store procedure, SQL Server basically compile very first time unless it is not changed. If it is changed, then it is compiled again. Otherwise, for the reusability purpose, it compiled very first time and then return the results over the period of time. And since it is like centralized business logic, so mental ability is also easy for us and it achieves the modularity. So these are the key benefits to use the stored procedure in the SQL program. Now look at the stored procedure with parameters. We have the stored procedures where we need to pass certain input parameters to get the result out of it. So you can see this stored procedure is expecting department ID as an input parameter, and the data type of this is integer, and this is going to return the result set from the department ID, which is being passed at the time of calling this store procedure. So you can see the execution of this. We are passing the department ID 10. So this procedure will return all the records of all the employees whose department ID is 10. So that's how we can parameterize the store procedure. Now, there are output parameters also written by the store procedure. So if you see the previous example, it is returning the data set completely or data table as part of the result. But sometimes we need to return a scalar value. And to achieve the scalar value or even the table, we can define the data types as part of the return value and use the output as a keyword in front of the variable name or whatever the input parameter we are passing at the time of creation of the store procedure, and then we have to return it. So you see, we are in the part of execution, we are declaring the count as an integer as part of our return parameter or output parameter, and then passing the get employee count as the total count. This is the same name we have to put up as output parameter, and this will return to the count parameter which we have declared here as an output, and then we can print or select. So this will return the value of total employees which are the part of this variable, and we need to use the same total count as part of the within the select query so that we can return the parameter as part of the output parameter of this store procedure. So that's how the procedure works with the output parameter. Now look at the multiple parameters we can pass. It is not as more than one parameter if required. Then we can actually do that particular thing by passing the multiple parameters. And the good thing is that with the procedure itself, we can insert the data within the tables. But in the case of functions, a scalar valued or multiple table valued function, we cannot actually insert the data within the physical table in SQL Server. So I think that's all about the SQL store procedures. And then you can also alter and drop the procedure by modifying its definition. Like earlier, we were showing the select star from this, but now we are putting up the name and department ID. So instead of create procedure, we use the alter keyword to alter procedure and get employees. So that's how we can modify the definition and we can directly drop the procedure. But for that, you have to have this DDL level operations. You must be having the appropriate access on the database object itself. Now look at there are like system procedures as well, like SP help text. So these are the system procedures which will return the definition. So for example, SP help return the table and column metadata. So this will return the entire definition of the SQL procedures. Uh, Return the number of the output in the table itself. The SP help text return the source code wrapped up within the SQL procedure itself. So this is how this SP rename will rename the procedure table name or whatever the database object we can do it. So these are the couple of the examples. These are the inbuilt function, the stored procedures, and I'll show you how we can see that. And we are not supposed to modify these because otherwise the functionality will be disturbed performed by these stored procedures. So these are the few tips, like use the prefix whenever you create any procedure, because for example, if I need to write, you can see that SP stands for stored procedure and then start with the name of the procedure. So these are the system level procedures. But if you see, I have used the USP that says that is the user defined stored procedure. So use the USP underscore, whatever the procedure name you would like to put in. Avoid using SQL star query because that diminishes the performance of the procedure. and then use the try catch block. So there is a error handling part related to the store procedures. So that we should use. And always we have to add the comments and the documentation for the better maintenance. So that also I'll go through you how we can actually cover it up this comment and documentation part in the real hands-on implementation. Now let's look at the functions. So there are like SQL functions, which are different type of functions like built-in function, user-defined function, and which returns the scalar value, and user-defined function, which returns the table result itself. So the way we write the store procedure, we write the function itself, wrap up the complex SQL logic within the function and store procedure. The only difference between the function and store procedure is that we cannot do the DML operation like insert, update, and delete within the function. And we cannot also, use these functions as part of these operations. Also, the functions are like compiled objects. So as I mentioned, in the case of store procedure, the store procedures are first time compiled and many time of executable. In the case of functions, every time whenever we call any function, it first compiles and then only return the value. So that is the core difference, and that is why functions are like slower in the performance over the stored procedures. Now look at the built-in functions. We have like get, date, length, upper, round. These are the built-in scalar functions which return us the single scalar value. While if you see the aggregate function, these are the other type of table valued kind of function which return the table outputs when we use within the on the table itself. Now you see the user-defined scalar function. If you see the get full name, we are passing the first name, last name as part of the input parameter and returning those values directly to the function itself, right? And to use the function, instead of using the execute command, we have to basically use the select statement as part of the function. So for example, if you see select function name passing the input parameter and then as full name we are returning. So this function will return the scalar value. Now let's look at the multi-statement table valued function. So you can see the create function get high value orders returns the result as a table. In previous example, you see that is returning the single value returns n varchar, that is a scalar value. But if you see this inline table valued function, it is returning as a table. So inline means is simply we are just giving the returns as a table statement, hinting to the function return this as a table. So we are just putting up this SQL query and returning it. So this will whatever the number of columns it is returning from single table. We need to use, as I mentioned, that select star from this table by passing the ID. Now you see multi-statement valued function. So the difference between the inline table valued and multi-statement is for the single table valued, we need to write a single select statement within the return statement. While multi-line, we can actually perform certain number of operations and then return a result itself. And here we are just passing the definition of the table. Instead of this particular independent keyword of the table, which is returning the number of columns, we are just writing the definition of the table, and then you can see the multi-statement. First, we are inserting this record into the result variable, which is this result table, and then returning this table as part of the return statement. As I mentioned that we cannot do the insert operation within the user-defined function. That means we cannot do the insert operation into the physical table. But here result is not a physical table. It is a just written variable in the definition of function itself. So you can see we are just getting that select star from this value itself. So that's how basically we can create the multi-statement table value. Generally, we identify them as a ITV and MTVs. So you can see the difference between the procedure versus functions. This return the value as part of the optional. It is not necessary. In the case of function, we have to define the return type, what kind of, whether it is a scalar or table valued, what kind of data is it is returning. We can modify the data within the stored procedures, but in the case of function, we cannot, as I mentioned, that we cannot do the insert, update, delete operations. We can use select. No, we have to use the execute keyword. For function, yes, we can do it. used in joins. So the procedure cannot be used in the joins, while the functions can be used within the joins itself. So for example, if we want to use this select star from this and join the columns from the output of this table, we can use it as part of the inner join, left join operations, but stored procedures cannot be. They support the transactions. Stored procedures support the transactions since we are manipulating the data using within the stored procedure definitions. But the function does not support because we cannot it does not allow to manipulate the data. Again, we have to use the prefix into the function like fnt or fn as we did it into the stored procedure. Avoid using a scalar function in large select queries. Use inline TVF instead of MTVs for better performance. So these are the basic best practices for using the function.
You are not competing with fellow job seekers or with your peers. You are now competing with AI. And how you are preparing for it? You are watching hundreds of YouTube videos and joined many online and offline courses, but still struggling to get a job? Do you know why? Because you only have skills and not hands-on experience. There are many courses on YouTube coding sessions which claims to work on capstone projects, but they are not based on real business scenarios. We at Practice help you to level up your skilling and upskilling game. We have deployed a platform where you can gain hands-on experience using our real business requirement, use cases, and capstone projects. We have deployed a platform of synthetic data sources which you can download in form of CSV, Excel, or can directly connect the online database using our sandbox feature. Our upcoming mentorship module will help you to connect with industry experts to answer your technical questions and help you create capstone projects. So do practice, prepare yourself, and become prosper. Join the revolution, join Practice now.
Let's have a look at our practice platform. This is a platform where you can practice, prepare yourself, and become prosper. This is a public page, which will give you a quick overview of what exactly a product is. You can see there are synthetic data sources which we have created. Now, to access our products and all our features, you first need to log in or create an account if you don't have one. Once you successfully logged in into the website, you will land up into a dashboard page, which basically contains your last 5 transactions and all the trending products. Now, here comes the main part, our products. We basically offer 4 categories: business requirement, capstone projects, data set, and use cases. As this masterclass is based on use cases, we'll discuss the use case products. This is a use case page where you can have all the use case products related to the use case. I'll help you to add one product and guide you how you can purchase one. First, you need to add the product into the cart. And here comes the process where you can purchase the product. On clicking on click to pay, you can successfully purchase the product. And after purchasing it, you can see your purchase in your purchase history section. Here, all the details of your purchase products can be seen here. Now, every product contains some assets, data sets in form of CSV, PDF, or Excel. You can download those assets from here. And once downloaded, you can read it and utilize it according to your need and practice. One more very important feature of our website is the masterclass feature. All the upcoming masterclasses will be visible here. And once you have registered for all the masterclasses, you can see those masterclasses in your masterclass session.
So in this example, we are going to discuss this restaurant performance and menu optimization. So for that, we have these restaurant order item, menu reviews, and delivery details data sets available, and the requirement use cases. So I've already downloaded them. If you see, these are the data sets which are attached to, and we can always click on the download them, and they will be available in the form of CSV. So those are available, you can see, downloaded. At the same time, if I download the use case document, that is also available into this. So I've already downloaded that one, and you can see this use case document. So to apply your existing SQL knowledge, you can actually go through this document completely. This will actually talks about prerequisites. So what kind of prerequisite it requires, like understanding of the aggregate function and group by clause, knowledge of the window functions, familiarity with the statistical concepts like average percentile, and what is the objective of this particular use case? To analyze the restaurant performance metrics, identify top performing menu items, optimizing menu of offerings to maximize revenue and customer satisfaction. And then what kind of skills you are going to use? You are going to use the Windows function like row number, dense rank, complex aggregation queries with the CT, and the performance ranking comparison and time series analysis. And after applying the your skills on this SQL use cases, you can actually write the basic to intermediate SQL queries, use the group by order by clauses, analyze the business data sets. You should be able to comfortably use the aggregate functions like sum, count, etc., and that mathematical functions along with the conditional logic. So this is what is the learning outcome out of this use case document. Let's look at the business background. So, what it is saying, in a competitive food delivery ecosystem, the restaurant partner require a data-driven insight to evaluate their performance and optimizing the operations. This include understanding how they compare to competitor, which menu items drive the most value, and how customer behavior affects the revenue. The use case helps answer questions such as how many unique customer does a restaurant serve, what is the average order value, and how does it trend it over the period of time, which restaurants are top performers in the term of revenue, order volume. And the this analysis empowers restaurant to improve their offerings, enhance customer satisfaction, and increase the profitability on the platform. So the purpose, so basically when it comes to working in any company or any job profile where the SQL skill is going to be used, end customer actually gives the similar kind of requirement to the developer, and they need to read these requirements and then perform the task. So that's the context of this particular use case. Now if you see this restaurant menu item, orders, order item, and reviews, these are the, along with this delivery details, is the data set which is going to be used. So this restaurant is basically containing the core details about the restaurant, its name, rating, and status, whether it is operable or not. Menu items like menu offerings, related information. Order contains the information related to the orders, how many orders every day we are getting, like total price, cancellation flags, etc. And the order item contains the breakdown of each orders, what items are being ordered, what is the quantity and all. And the reviews stored the customer feedback, what we give to the after food delivery. So this is the data sets. Now, how we are going to use these data set? So to write any sort of query, we have to basically first dump that data set into a database, and then only we can write all those queries. Okay. So to for that, what I need to do first, I mean, prerequisite for this particular use case to implement, we have to have the SQL Server installed. And if you have the SQL Server installed up and running, what you can do, you can go and get connect this by your local database, connect it, and once you are connected, you just go to the database folder, right click on this and click on the new database, and click the this test Zwiggy database, this will actually create a blank database for you. Now we need to basically dump all these data sets over there into the database. So what I'm going to do, I'm just right click on that database and then click on the task and import the flat file. So for that, I need to just click on next, browse the file. Let's suppose I'm just loading the order. So what would be the target table name we need to define here, and table schema in which it is going to be created. And then go to the next. This will show you the data preview, which is there into the file. And then here, whatever the column names are exist into that CSV file, that will be showing. And here, by default, the data types for each column read by the this import file feature, and we need to change the data type from small int to int because CSV contains large values which are more than out of the range of the small int. So we have to change from small int to int, and then wherever we see the date related columns, we have to convert from nvarchar to date time. So created at and updated at, we have to change this to date time. Restaurant ID to int, order status, price, order date. Okay. And then finish it off. So this will load the data for you. Into the table, you go to the table and just refresh it. And then you can see the orders table is ready for you. So you can just write a simple query and then you can see the data which is there. Okay. Now why I'm able to change the data types. I have done my data analysis before on the this data set by opening this Excel file and see what kind of uh, data types are available. So I can see this is the date time column, this is the pricing column. So that's how I got to know what is the value into the CSV file. What are the different data types can be applicable to different columns. So if you don't know what data type I need to select, you need to first analyze the data set in CSV level, then only you can select it. Now I would show another table to be loaded quickly. Click on this, click, let's say that menu items, this one. I need to remove the space, though I can keep it up, but still we can just follow the standard naming convention of the tables. That's why I removed the space from there and then use the date. Here also date, teaser. So here again you can refresh this one, this entire database, and now you can see menu items are loaded and you can run this query. So that's how you can load those CSV file into database and then start writing your queries. Now let's come back to the use case document. So you can see the first use case. So here we have like listed 5 use cases to be solved using those data sets what we have loaded into database. So first data set is basically capturing the restaurant performance ranking. So what we need to do here, if you see, we need to rank restaurant by multiple performance matrices, including revenue, order volume, and customer rating, right? And what would be the business impact for the restaurant? Helps to identify top performing restaurant for partnership expansion. So the intended audience, like for example, Zwiggy operation team want to see who are the restaurant who are performing very well, so they can actually ask for the analytics team to find the top restaurant in terms of the revenue, order volume, and customer ratings. And the expected outcome should be like this. So, for example, if you see this expected outcome, the it is listing down the restaurant name, total number of orders, what is the total revenue, average order value of what they are receiving, restaurant, what is the restaurant rating, how many unique customer they have served so far, the performance score, their revenue rank out of all those, restaurant order volume rank, and you can see since this order value rank is one, it serves to the highest customer and the performance category, whether they are falling to good, average, something like that. So just to write this particular thing, you can see this use case query one, which we have written already as part of our solution. So we can run this. We have to use Swiggy since I have already loaded all the data. So you can see this restaurant, total orders, total revenue, all those things. But you cannot write this query directly. For that, you have to identify the data and understand that. So let's start looking at that. What it is, the data set is giving us total orders. So first we need to identify, since we need to return the restaurant name and then return the count the total restaurant. So for that, we have to look at the table first. Okay. So dbo dot restaurants and then dbo dot orders. So these two tables we see, okay, from where the restaurant and name is coming. So we copy the restaurant name from the table itself of restaurants, and then just we need to calculate the order ID, which is the primary key in that case. So we are going to write the order ID. So what we need to do, we need to count the order ID, right? And we need to get the restaurant name. So these two we can get it. But if you see, we have the restaurant ID as a foreign key. So in this session, what we have learned already is inner join. So we are going to use the inner join, give the alias R, put the inner join on DBO orders. O on R dot restaurant ID equals to O dot restaurant ID, and return the table name as the column name as total underscore orders. Now you can see, and as I mentioned that we have to use the group by clause since we are using the aggregate function. So we have put it up the group by clause. Okay. So now it is completing this. As part of this solution, we have this, for example, we can compare this by restaurant name. Here also we can put the same condition from the query, the solution query to the query which we are writing. Okay. As I mentioned that one more thing, since we are using the with and it is giving the error, so we have to remember one thing, that the whenever we are using the CTE, the previous query should always be end with the semicolon, so that that can capture the scope. As I mentioned in the definition of the CTE,
What it is saying, a CT is a temporary result set defined within the execution scope of single SQL statement. So just to this is the CT completely, and to define the scope of the query. So how SQL engine will actually analyze the scope or identify the scope of the CT. So for that, we have to terminate the previous query with the semicolon. Then only SQL will identify that previous query is ended and the CT execution start from this line until this semicolon. So that's how the stuff is basically the scope is defined by the SQL Server for given this. Now you can see it is returning 19 and it is returning 12. There should be a kind of filter condition which we have to suppose we have to put as part of the business requirement. So if you see, I'm just in this case it is the left join, but here we are putting up the order cancellation and uh, the payment status as true. So payment status should be true and order should not be cancelled. So I'm just going to repeat the same condition. Now let's see. Now it is returning the equal amount of a number of rows or number of totals order from the both data sets. Okay. So thus far we created the total count. Now this total revenue as a use case itself is defining what is the total revenue. So for the revenue, what we need to look at it. We have to check what table is returning the revenue part. Okay. So we have the orders table which contains the total price. So I believe total price is also used over here, right? Since we need to calculate the different parameters of the output like average order value and total revenue. So for that we have to use the aggregate function. Sum of the total price revenue and average order value. So this one, let me save this one for. So now I'm running this one. And you can see there is a difference still coming on this number. Total total revenue, sorry, average order value. So you can see the average order value is something which is matching the same number, but total revenue is still falling short. So now we can see what kind of joining condition we have over here. The revenue are, so the restaurant should be is active. So let me check this. Putting this one. Okay, So this could be because we are using here left join. So let let us try the left join as well. Not because of this. So anyways, numbers we can actually see later. And then you can see, so this is the one of the complex query what we have written using different matrices and then performance ranking, right? So you can see I put it up this particular uh, ranking another subquery and we can write sorry CTE, we can write multiple CTEs by just putting up the comma, give the new CTA name. So with is the always tells to the SQL server that we are using the CTE over here, but that can be actually written with multiple comma separated CTEs as well. Now if we see another query restaurant matrices from the by joining this restaurant matrices from outer query and referencing to another uh, CTE. So this is just a removal of the score related subquery what we talked about. So this will return first, execute this and then that, and this will return this completely. This performance ranking CTE will run out the subset of the restaurant matrices, and then we are returning this entire stuff. And we are how we are basically managing the performance, calculating the performance score. Any restaurant whose performance score is greater than or equals to 80, then excellent. If it is 60, then good. And if it is this, then falling between this, then average. And otherwise, we need to put up the needs improvement. Okay. So here you can see this particular thing, and here we are using the ranking, revenue ranking by total revenue, order ranking by total orders, how much we are receiving, and the average order value ranking based on the ranking row number ranking function, average order value itself. Okay. And then we are just creating this round function as a performance score. So what we are doing, if you see total revenue, what we are calculating from where it is coming from the first CT total revenue, and then we are just checking the null f egg and max total revenue how much it is, and just multiplying 0.3. So that's how we are just keeping up this performance score how much it is coming overall. So let me remove this one and run overall queries. So you can see the performance score is calculating based on that. So this is how we write the query for the first use case. Now let's look at the second use case. Now what it is saying, top selling items analysis. So in which in this particular use case, what we are doing, we are identifying the most popular and profitable menu items. In the first use case, we were talking or looking at the talking about the performance of the restaurants, but here we are just looking at the numbers related to the top selling menu items. And here you see what it is the impact, help restaurant to optimize their menu mix and pricing strategy, potentially increase revenue by 20%. And what could be the expected output? So what we need to do, we need to show the menu items, restaurant name, menu item price, what is the base price, times order, how much time it is being ordered by the end customer, total quantity sold, total revenues, how much this menu item is being sold by the restaurant, and how much total revenue this menu item generated, revenue revenue per order, unique customers, like how much we are earning the revenue per customer itself, and then how many unique customer we have received so far. So let's say that 180 times is total this menu item is ordered, but unique customer is 142. So out of these 142, there are like many customer who repeated that popularity rank, revenue rank, and the item popularity. So this, for writing this kind of query, we need to understand again the data set from the menu items. So first look at the menu items data table, and that contains the menu item ID, restaurant ID, item name, description, item price, what is the base price, and whether it is available or not. So these are the items. Here you can see the restaurant ID is also available, and the uh, we can match this with the restaurant ID. So let's see the second use case query. Again, what we are doing, we are just selecting the menu item ID, name, item price, base price, and then again counting the total times order it is, right? Sum of the quantity, how much many times it is ordered, how many quantity ordered, and the average price. So this is how we are writing the first use this the base query within the expression of the CTE, and I have just commented this 90 days interval. Reason being, we do not have the current date kind of comparison, so that's why I have just put it up as a comment. But if we have the latest data from the current date, then we can use this condition as well. And then we are again generating the item ranking, and then selecting the final result. So if we run this query, to change the database. So here it is returning the similar result what we have executing here. Okay. Third one is the restaurant revenue trend analysis. So this is the analyze monthly revenue trend for restaurant to identify seasonal pattern and growth opportunities. Okay. And what it is doing, the impact is that help restaurant plan inventory, staffing, and benchmarking and marketing campaign based on the demand patterns. So monthly revenue trend and growth rates and seasonal insights. So this is what we need to do with this particular requirement and the SQL which is written for this. And let's look at the output, what output it is returning. So the restaurant name, most active months, like month active, total revenue. So month active will explain total revenue in last 12 months, average monthly revenue, revenue volatility, average monthly growth rate, and growth category. So you can see I have this written this query like restaurant ID, restaurant name, revenue month. So what I'm just doing, I'm getting the month in which it is getting the revenue. So this will return multiple times, count of the total orders, sum of the total price again, and then see the trending analysis based on this inner query. So this is how you can actually calculate. We are calculating the standard deviation as part of the volatility as well, and using the lag function of the SQL Server, which will calculate the compare the revenue from previous month over the period of time. Okay, and then based on the average growth rate, we are just parameterizing based on the number 5 and keeping this, if it is average growth rate is 5% per month over month, then mark it as a high growth. Otherwise, if it is zero, study on the same trajectory of the growth, and if it is falling, then stable, and otherwise it is declining. So that's the use case of use case number 3. Similarly, menu item profitability analysis. So one restaurant which is having the multiple menu items, but they need to identify, okay, which particular menu item is actually profitable or not. So that kind of analysis we can do with this. And for that, if you see, what we are calculating is average selling price, what average selling price we are getting, what is the listed price, what is the estimated cost per item, profit per item. So these kind of analysis you can put it up. So this will help to the restaurant owners or the on the Zwiggy platform, that they can actually analyze their menu item performance. So the query for this we have written, again the baseline query almost remains same, and we are just checking based on the different parameters. Minimum order should be greater than 50, or median is like 20 parameters we have kept for the volume category. And then otherwise it is below than 20, then it is low volume kind of thing. And then you can see profitability margin percentage we are keeping. So you can see we have calculated inside that query and put it up like 70 for the high volume or star performer for the uh, high volume category with the highest profit percentage, 60 or 40 and 20, then high margin, good margin, low margin. Otherwise, we are recommending review the prices. Okay, if it is 20% profit margin on any menu items. And then if you see the pricing recommendation, if we need to keep the more than 40%, so we are putting it up. If somebody wants to achieve the 40 per more than 40%, we are recommending that the product you should basically increase the by 40% itself. So that will be like improvement recommendation we are talking about here. If it is like performance optimal, then we are just giving the numbers based on the 80. So that's how we are just returning this particular thing. And then we have this use case 5, restaurant capacity and efficiency analysis. And for that also we have written this the large query, right? So where we are just calculating the efficiency separately, peak order hours, uh, restaurants peak hours, order peak hours, or peak hours count order, all of that, and then just calculating the efficiency metrics, and then returning the query. So that's how you can actually write those complex SQL top of that, and that required a very hands-on the the SQL skills to achieve write these all queries. And SQL is like most important, like the way I have shown the current complex queries. These are the, if somebody has that level of skill set on the SQL side, then they can actually easily crack down into the data engineering role like ETL engineers, like they get into easily into the machine learning, because they understand the data, how relationship is working, what kind of potential that data has to build the machine learning model. So that is where learning and practicing the SQL is more essential. Whether you are getting into analytics role and using the tools like Power BI, Tableau, or Google Studio, if you want to do the ETL engineering using Microsoft Fabric or AWS Glue or Databricks, then again understanding of the data is much more necessary. So that is where we recommend it to basically get these SQL use cases and then get them solved. And obviously you can always look for the solutions on the internet as well, how we can actually apply different use cases on these data sets.